Hello everyone, in this video we are going to learn about similarities in a right triangle. At the end of this lesson, we are going to explore the similarities formed in a right triangle when the altitude to the hypotenuse is drawn. Secondly, we are going to use geometric means in solving problems involving right triangles. So to start with, let us consider this given figure. In this figure, we have here triangle ABC wherein angle C is a right angle. Suppose you are going to draw the altitude CD, and this CD is perpendicular to the hypotenuse of the triangle, which is AB. Now, if we are going to consider this correspondence, ACB corresponds to ADC, then the angle pairs are corresponding. So angle A corresponds to angle A, angle ACB corresponds to angle ADC, and angle ABC corresponds to angle ACD. So with this correspondence between this pair of angles, we can say that angle A is congruent to angle A by the reflexive property. Angle ACB is also congruent to angle ADC because based on the figure, they are both 90 degrees or right angles. So therefore, since two pairs of corresponding angles are congruent, then by the AA corollary, we can say that these two triangles are similar. Accordingly, we can also get the correspondence ACB and CDB, wherein these three pairs of angles are corresponding. And we can also say that angle B is congruent to angle B by reflexive property, and both angles ACB and CDB as shown in the figure are right angles, therefore they are congruent. So since we also have two pairs of corresponding angles that are congruent, then again by AA corollary we can say that triangle ACB is similar to triangle CDB. Thus, if we consider these two similarities, we can therefore conclude that the three triangles which can be deduced from this figure, the three triangles are triangle ADC, triangle ACB, and triangle CDB. Those three triangles are similar. Now let's look at the right triangle similarity theorem. So we are going to restate it, and here we have a figure to support this theorem. Let angle C be a right angle of the biggest triangle, which is triangle ABC. So in triangle ABC, angle C is 90 degrees. And then we have here segment CD, and this segment CD is called the altitude. So this is the altitude to our hypotenuse. So our hypotenuse here is AB. So ang ibig sabihin niyan, si CD, which is the altitude, is perpendicular to the hypotenuse, which is AB. Hence, we can form the three triangles. So nasaan yung tatlong yon? So you have here the biggest triangle, which is triangle ACB or ABC. Okay. Another triangle, we have here triangle ACD. Ito yun. And the last triangle, we have here triangle CBD. D. Okay? And those three triangles are considered similar by the right triangle similarity theorem, or what we call as RTST. Now, since we have here three pairs of similar triangles, then the following proportions can be formed. So we have here first equation, second equation, and third equation. So if we focus ourselves with the first equation, notice that on the left side, meron tayo ditong CD. And on the right side, meron ulit tayong CD. So if we rewrite equation 1, we can use cross multiplication to get the following. No? So AD multiplied to BD is equal to CD times CD, which is CD squared. Now, if I want to get the square root of both sides, I can say that CD is equal to the square root of the product of AD times BD. Okay, so that's the first equation when I rewrite the proportion. Similarly, we can do the same for proportion 2 and proportion 3, because in proportion 2, meron tayong AC, both sides. So, using the same method to solve for AC, I can say that AC is equal to the square root of the product of AD times AB. And lastly, for proportion 3, meron naman tayo ditong BC on both sides. So by cross multiplication, we can solve BC is equal to the square root of the product of BD times BA. So again, let's focus now on these three equations. So based on our figure, CD, which is the altitude to the hypotenuse, is equal to the square root of the product of AD and BD. Okay? And for number 2, AC, which is a leg of the biggest triangle, okay, is equal to the square root of the product of AD, this one, and the entire hypotenuse AB. And lastly, for number 3, we have BC, which is another leg of the biggest triangle, that is equal to the square root of BD, this side, times the length of the whole hypotenuse. Okay? So, how can we restate those three equations na nandito sa ating screen? So, we have the corollary to right triangle similarity theorem, and the following statements are true. So, if we are given a right triangle with the altitude to the hypotenuse as shown here, then the following can be said. Number 1, the altitude is the geometric mean of the segments into which it separates the hypotenuse. So take note of the word geometric mean. Okay? And second statement, each leg is the geometric mean of the hypotenuse and the segment of the hypotenuse adjacent to that leg. Okay, so medyo mahirap i-visualize if walang supporting figure. Okay, but before we look at the figure, so let's recall, ano ba ang geometric mean? Okay, so geometric mean is a positive number that satisfies this proportion. No? So if we are going to simplify this proportion, we can solve this as x is equal to the square root of the product of a and b. So example, if we are going to find the geometric mean of 4 and 9, so we can say that the geometric mean x is equal to the square root of the product of 4 times 9. So this is 4 times 9 is 36. So square root of 36. We only need to get the positive root. So x, or the geometric mean, is positive 6. Okay, and another example, if we want to get the geometric mean of 6 and 15, so that is square root of 6 times 15. 6 times 15 is 90. So the square root of 90 is positive 3 square root of 10. Okay? So let's proceed to the illustration of the corollary to the right triangle similarity theorem, or the RTST. So we have here another version of the three similar right triangles. No? So this time, the following segments are labeled as A, B, H, M, N, and C. So for H is your altitude to the hypotenuse C. And H, ang sabi sa corollary kanina, H is the geometric mean between the two segments which form your hypotenuse. So in this figure, your hypotenuse C comprises of segment M and segment N. Therefore, if we are going to express that as an equation, so H is equal to the square root of M times N. So that's the first statement of the corollary to the right triangle similarity theorem. Then for the second statement, let's reread it again. Each leg is the geometric mean of the hypotenuse and the segment of that hypotenuse adjacent to that leg. So looking at it, so we have here B as one leg of the biggest triangle. So if we want to solve for B, that is the geometric mean of the hypotenuse, which is C, and the length, which is adjacent to that given leg. So ano yung side na adjacent kay B? So that is segment M. Okay? So B is equal to the square root of M times C. And for the third equation, so suppose we are going to get the value of the other leg, which is A. So A is the square root of ano yung adjacent kay A, that is N. So that is square root of N times the whole length of the hypotenuse, which is C. So A is square root of N times C. So at first, this figure seems to be very confusing because of the many variables present, no? But for me, ang ginagawa ko palagi ay, so step 1, I determine kung nasaan yung biggest triangle. So, di ba sinabi natin kanina that we have three similar triangles? So, I'm going to locate the biggest of them all. Okay, so that is triangle ACB. So, ito yon. Itong mamarkahan natin ng blue. Okay, so that is the biggest triangle. So, we know that all of those triangles are right triangle, no? So, let's determine ano yung step 2. What is the altitude and what is the hypotenuse of that biggest triangle? Okay? So, I'm going to label or ito yung naming convention na gagawin ko. So, for altitude, I'm going to call that alt. And for hypotenuse, I'm going to call that HYP or hype. Okay? And then step 3. So, aside from determining hypotenuse altitude, I'm going to determine also the two legs. So, I'm going to term them leg 1 and leg 2. Okay? And I'm going to call also the adjacent segments to these legs as adjacent 1. So, ito yung katabi ni leg 1. And adjacent 2, ito yung katabi ni leg 2. Okay? So, if I'm going to use that symbols or notations in this figure. So, nasaan si altitude? So, ito si alt. Okay? Nasaan si hypotenuse? So, ito si hypotenuse. Hype. Okay? So, kung ito yung hypotenuse, then ito yung leg 1 at ito yung leg 2. So, this is leg 1. This is leg 2. So, nasaan si adjacent 1? So, katabi ni leg 1. So, ito si adjacent 1. Nasaan si adjacent 2? Katabi ni leg 2. So, this is adjacent 2. Okay? So, ang gagawin ko, step 3 or step 4. So, I'm going to form my equations. So, based on the corollary to RTST, si alt ay equal kay square root ni adjacent 1 times adjacent 2. Okay? And alam ko din that adjacent 1 plus adjacent 2 equals my hypotenuse. So next, paano ko naman kukunin si leg 1? So kung si leg 1 ang gusto ko, yun ay square root ni adjacent 1 times hypotenuse. And kapag gusto ko si leg 2, so siya ay adjacent 2 times hypotenuse. Okay, so don't forget na meron tayong square root kasi geometric mean. Okay? So let's look at some examples here. So in this figure, we have given 3 right triangles. So applicable dito si RTST or the right triangle similarity theorem. And we are going to solve the values of the variables x, y, and z. Okay, so again, pwede kong gamitin dito yung technique na binanggit ko kanina. So for number 6, ano yung aking alt? Altitude is equal to y. Okay. Ano yung aking hypotenuse? So hypotenuse is always perpendicular to your altitude. Therefore, hypotenuse is this one. Okay. And that is 6 plus 4, which is equal to 10. Okay, so I'm going to call this as my leg 1 and this as my leg 2. Okay, so x is leg 2 and z is leg 1. Okay, so kapag gusto nating hanapin si x, so that is leg 2. Ano yung value ni leg 2? So that is adjacent 2, which is 6, times the hypotenuse, which is 10. So, x is equal to square root of 60. Okay? Kapag gusto ko naman si leg 1, which is z, that is the square root of adjacent 1, which is 4, times the hypotenuse, which is 10. So, z is square root of 40. And lastly, if I want to get y, which is the value of altitude, so that is the square root of adjacent 1 times adjacent 2. So that is 6 times 4. That is square root of 24. Okay? So that's how you solve for the missing parts of the given triangle. Okay? So applying the same to item number 7. So for item number 7, we want to solve for x. Okay? But x is equal to adjacent 1. So if I'm going to label this as altitude, leg 1, leg 2, adjacent 1, adjacent 2. So in order to solve leg adjacent 1, so kailangan mo muna yung other equations, no? So if we are going to use the formula altitude is equal to the square root of adjacent 1 times adjacent 2. So substituting, altitude is 10, adjacent 1 is unknown, which is x, and adjacent 2 is equal to 20, no? So we have here one equation, one unknown. We can solve for x, get the square of both sides para matanggal yung square root. 10 squared is 100. Then cancel, this is 20x. Therefore, x is equal to 100 divided by 20, which is equal to 5. Okay? So after solving for adjacent 1, so this is 5. Then we can get hypotenuse, because hypotenuse is just adjacent 1 plus adjacent 2. 5 plus 20, that is 25. Bakit natin sinolve sa hypotenuse? Because we're going to use that to solve for y. So y is leg 2. That is the square root of adjacent 2, which is 20, times hypotenuse, which is 25. So y is, using my calculator, square root of 20 times 25. That is 10 square root of 5. And solving for z, that is leg 1. Leg 1 is square root of adjacent 1, which is 5, times hypotenuse, which is 25. So the square root of 5 times 25 is equal to 5 square root of 5. So those are our three values.